Hello. Let's evaluate this integral. I equal to integral 0 to infinity tan inverse of 1 by x whole square dx. Right? It looks somewhat tricky. So let's apply some parameters. Let's make I a function of a comma b, which is integral 0 to infinity tan inverse a by x into tan inverse b by x dx. That is I is I of 1. Sorry, I is I of 1 comma 1. If a and b are 1, then it will be tan inverse 1 by x whole square, right? So let's start. Then let's do one thing. Let's do dou I by dou a. Then this will be integral 0 to infinity. As we are doing partial differentiation with respect to a, tan inverse b by x will be unchanged. Then it will be 1 by 1 plus a by x whole square into 1 by x dx, right? Which is integral 0 to infinity tan inverse b by x into denominator is a square plus x square into x square 1 by x dx. So finally dou I by dou a is integral 0 to infinity tan inverse b by x into x by x square plus a square into dx. So if you differentiate a again with respect to b, then it will be dou square a by dou b dou a is, it will be of similar form, right? This will be it will be same as for a case, right? So x by, that is we got x by x square plus b square, which is finally integral 0 to infinity x square by x square plus a square into x square plus b square dx. So let's apply a small trick here. Then dou square I by dou a dou b. As you can see, these are both the same. Then let's do a trick here. Integral 0 to infinity. Let's multiply a minus b x square by x square plus a square into square and divide with a minus b. Right? Can we do some simplification? No, right? So let's do one thing. Let's add and subtract minus a square b square plus a square b square. So let's see if we can make some simplifications. Then dou square I by dou a dou b is 1 by a minus b into integral 0 to infinity. So um, what will you make the substitutions here? Sorry, we cannot make much simplifications, right? We need to multiply and divide with a square minus b square so that you can take simple common factors now. Now make it try. If you take this guy and this guy, common will be a square, right? A square will be common. This will be a square plus b square. Then the remaining two terms are this and this. You take minus b square common with the then this will be x square plus a square by x square plus a square into x square plus b square dx, which is 1 by a minus b into, as you can see now, integral 0 to infinity. This will get a square by x square plus b square will get cancelled in the first case, then it will be a square x square plus a square. Similarly here, x square plus b square dx. Right? Then let's integrate this case. Dou square I by dou a dou b. You must remember this is a function of a comma b. Right? Then this is 1 by a minus b into, as you can see, a square, you can keep it out of the integral. Then 1 by x square plus a square is 1 by a tan inverse x by 8, 1 by a tan inverse x by a integral 0 to infinity. Similarly, for this case, minus b square into 1 by b tan inverse x by b. Integral limits are 0 to infinity. So this a will get cancelled. Here the b will get cancelled. 1 by a minus b into, as you can see, if you substitute the limit here, there will be 1a. Tan inverse infinity is pi by 2, right? And tan inverse 0 is 0. Similarly here it will be b into pi by 2, right? So we have here it's a square minus b square, right? Then it will be 1 by this, you can write it as a minus b into a plus b. Then this is, you can take pi by 2 comma a minus b. A minus b will get cancelled. This is pi by 2 into a plus b. So finally dou square a comma b by dou a dou b is pi by 2 into a plus b. So finally we need I. I is I of 1 comma 1, right? Which is pi by 2 into, to get I we need to subtract, sorry, we need to integrate twice, pi by 2 into a plus b dA dB. What about the integral limits here? Because I is from 0 to infinity, right? It must be from 0 to 1. Why is it so from 0 to 1? Because if, as you can see, I of a comma 0 is 0, I of 0 comma b is also 0, right? Here the a comma b, if a is 0, tan inverse 0 is 0, then this will be 0. If b is 0, then tan inverse 0 is 0, then either of a or b it will get 0. So it will start from 0, and when it gets to, we need to find up to a equal to 1, right? So 0 to 1 will cover the entire part. Then integral pi by 2 into, the first case it will be, do the integration limits of 0 to 1 a. Then this will be, do for the a case, then we'll do, this will be n ln of sorry, this is 1 by a plus b, right? This is 1 by a plus, as you can see here, it is the part remaining, it is in the denominator, not in the numerator, it is denominator. This is then ln of a plus b right? 0 to 1 into dv, as we have done with a with respect to a. This is pi by 2 into integral 0 to 1. If a equal to 1, this will be ln of b plus 1. If a is 0, this will be ln of b, right? And this is dv. Similarly, if you do this differentiation, as you know, integral ln x is x ln x minus x. If you substitute these things, then finally you get pi ln 2. Final line, integral 0 to infinity tan inverse 1 by x whole square dx is pi ln 2. This is the solution.